Hey everybody, it's Mrs. Lawson, and I had some requests to make videos for these showcases, our ICANN statements, and so this is the answer key for ICANN Assessment 6. So in number 6, what we had to do was make a piecewise function. So I'm going to color mark these. So the first thing I'm going to do is just address the fact that these piecewise functions are going to have these walls. So I'm going to be looking at everything to the right of those semicolons. And my first function, the 1/2 x plus 5, will have to be in the area where x is less than -4. So what I'm doing right now is I'm going to mark where -4 is. It's my imaginary wall, and it's going to be to the left of it, so I'm going to kind of shape it off like this. Okay? My next section is going to be in an area from -3 to -2 if you look here. So in green, here's my wall for -3, and then it will be up to 2. So in between those two green lines will be the -x minus 2. And then finally, my fourth function will have to be where x is greater than 2. So I'm going to take orange and kind of weave it in and out so you can see a little bit of both orange and green there. But it will be to the right, so I'm going to put these little sections there. So let's go ahead and start. In the blue, I'm going to graph my first function, this 1/2 x plus 5. And just to note that I should begin at 5. And that my slope is 1/2. I rise 1, I run 2, and that line is going to be going uphill when I look at my graph from left to right. So what I'm going to do is I'm going to start at 5, and remember we start on the y-axis, so make sure you're starting on the line where you see 10, 9, 8, 7, 6 going up and down. So there's 5. Now I actually am not going to need this point, but I'm going to keep this point for now, and I'm going to get the part that I need to graph. So, whoops, sorry about that. I should be going up 1 and over 2 to the right, which if I put a dot right there, I don't need anything to the right of it. So instead I'm going to be going down 1 and to the left 2, and I'm going to keep putting these dots until I get to that segment. And so in that section you can see this blue on blue. That's the first actual line that I want, or point that I want, I'm sorry. So I'm going to keep going down 1 over 2, down 1 over 2, down 1 over 2. And so as I graph left to right, it is going uphill, but I'm going to be putting an arrow on the left side because there's no wall to stop it. And on the right side, because this inequality is not underlined, I will be putting an open circle right there. Now these other points that I put, I'm going to erase them now because I don't really need them. And as I did that, I erased my 2 lines. This is the downfall of using my computer instead. Okay, so I'm going to fix that real quick. So you still see those boundary walls. All right, next one I'm going to go to is what I did in green. So in green, I'm going to be graphing beginning at -2. Whoops. And my slope is a -1 over 1, which will be going downhill as I go left to right. So again, I'm going to begin on the y-axis. I'm going to begin at -2, and I'm going to go up 1 and over 1, so I get a downhill look as I look from left to right. And this is a great one to graph because the points that I want are actually all in between those green lines, and that's all I want. I don't want the line to extend beyond the green line, so I'm going to connect them. And then because this inequality by the -3 is underlined, I will be putting a closed circle. And because with the 2 it's not underlined, I will be putting an open circle. The final one I'm going to graph is just the last one, 4. So if you notice, there is no slope. There is no number next to x. There is no number married to x. So I'm going to begin at 4, and no slope is just a horizontal line. So I could extend it all the way across from left to right of the graph, but remember, I only want it in this section here. So you can maybe see that I'm retracing it. And so going to the right 4, like this, since nothing's stopping it, I will put an arrow there. And because that inequality is underlined, then on the wall, I will be putting a closed circle. All right. Let's go to the next question. So this time you're going to write the piecewise function. So since we have 3 sections, I will be using Let's see, can we hide this? I don't even know why this is there. Well, I don't know if you can see that or not, but anyway, I'll be making 3 of these different equations. So I'm going to start with this first one. I'm just going to put all my information here. So for every line, I do need a y-intercept and I need a slope. Right now, I can't see the y-intercept, but if I just keep this line going, I'm going to see that my y-intercept is 4. Now, there is no slope. A sloped line is an angled line. This has no slope. So if you really want to put no slope, you could put 0. So when you write this first equation, you could put 0x if you want, or you could just put 4. I'm going to go ahead and put the 0x. Actually, I'm not going to. I'm just going to put 4 because that's not how we would normally see it. Now, this line is right here on the line. It's starting right here on -4, and it's going to the left. So the x's are to the left. I'm pointing my inequality left of -4. And I'm going to erase this line real quick because I want you to see that this is an open circle. So I will not underline my inequality in between the x and -4. All right, next one. This one I can see that my y-intercept is -3. And now I'm going to find the slope. So I'm going to start with one easy point and go to my next easy point, which happens to be the y-intercept. And if you look, you're going to rise 2, and you're going to run 3. And since the line is going uphill from left to right, I will leave this as a positive 2/3 as my slope. So I can write the equation 2/3 mx plus b. You could also do -3. And now when you look, I want you to realize that this is in between this -3 and 1. On -3, I'm going to do a little erasing here, you're going to see that closed circle. So at -3, I'll be underlining. And at the 1 line, you're going to see an open circle right here. So I won't underline for the open circle. So that segment was in between -3 and 1. And then my last one. So I'm going to do a little erasing here because here this is definitely tougher. It is much harder to see that y-intercept. So what I'm going to do first is establish the slope. And I'm going to take an easy point, like here's an easy point, there's an easy point, there's an easy point. And I'm going to establish my rise. So I'm rising 3 and I'm running 1. So m is 3/1. Notice that the line is going downhill from left to right, so I'm going to make that slope negative. But what I can't see is the y-intercept. So from this point right here, I'm going to rise 3 and run 1, and you're going to then see that, hopefully you see that your y-intercept is at 5. So I can write my equation -3. You could also put -3/1 x plus 5. Now this one, if we look at the wall, let's switch colors, is on the line on the wall of 1, and then it's all to the right of the wall. So my x, I'm going to use the highlighter, is going to be to the right or greater than 1. Let's check out that open circle. So I'm going to have to do some erasing. That is a closed circle right there, so I'm going to underline. All right, next one, 1.4c. You can evaluate a piecewise function. So just a reminder, all of the f functions go with the picture, and all of the h functions are going to go with the equation. So first I'm going to start with the picture, and just remember, I will give you a direction to go up or down. Once you go up or down, you need to look left and right to make sure you get all the answers, or if I tell you to go left or right, then you will have to look up and down to make sure you get all the y's. So on A, since the number's in parentheses, I'm giving you x is -6. So I'm going to use my little highlighter here, and I'm going to go to where x is -6, so I'm going left 6. Once you go left 6, it is your job to go up and down, which there is nothing down, to get that point. So if I look at how many when I went up 2. All right, let's take a look at another one. So this time I'm giving you x is 0. So x being 0, I actually don't have to go left or right. I'll just start at this 0, and I'll go up And when I do, I land right here. That is a closed circle, and I'm going up 2, closed circle included. But I could also go down, and if you go down, I want you to realize that you're going to be in an open circle, so we shouldn't include that amount. All right, I'm going to erase these colors, and now I'm going to go into the last one. So if this time the number's not in parentheses, so I'm giving you 4. So I'm telling you to go up 4, so you're going to go up 4, but once you go up 4, you need to go left, and you need to go right. And if you go left, your x is at -9, and if you go right, your x is at 2. So remember, look both ways. All right, next one. So this time I'm going to use the function, and we're going to be using these over here to determine which equation to use. So -6, I want you to realize with the graph, you can kind of cheat here. That -6, so does -6 fit here first? So is -6 smaller, or is it to the left of -2? And if you look up here, there's -2 and there's -6. -6 is to the left of -2. So in the past, I would mark these like maybe triangle and square and circle. So I'll be using, gosh darn it, I keep hitting buttons, the triangle here. So I'm going to go to my equation 1/2 x minus 6, and I'm going to put that 6 in there. And when you take half of 6, you get 3, and then 3 take away 2 is 1. All right, let's try the next one. So where is 2 going to fit? So 2 is not to the left or smaller than -2. 2 doesn't fit here because I would need this inequality right here to be underlined, and it's not. And then in here, if I put 2 there, I would also need that inequality because right now it should be greater than 2, not equal to 2. So this one I won't be able to use anything. This is what we would call a no solution. And then finally, where does -1 fit? And -1 fits in the middle, because -1 is in between -2 and 2. Going back up to the graph, and the green, you still see the -2, and over here is 2, and there's 1. See how it's right in between? So I'll just use this equation, which the nice thing is there's no math, it's just going to be 2. All right, let's get into the absolute value. So please remember that absolute value is going to have 2 answers, and my job is to isolate the bars. So the first thing I'm going to do is subtract this 4, and -4 take away 4 is -18. You might want to use a calculator. And now I'm going to move the 3 by dividing, and when I'm done, I get the absolute value of x equals -6. And already I know that this is going to be no solution. And the reason why is because when you do take the absolute value of something, you should always be getting a positive number, not a negative number. So that's why it's automatically no solution. All right, on the next question, I'm going to isolate the bar. So I'm going to divide by -2 because that -2 is multiplied there. So then I get my absolute value bars equals 10. And now I can make my 2 equations, x plus 3 with 10. X plus 3 with -10. When I subtract 3 on this equation, I get 7. But when I subtract 3 on this equation, I get -13. So those are my 2 answers. And write them like this. Don't put them in parentheses or brackets. That means something else. On the inequality, I'm going to do the same thing. I'm just going to ignore that the inequality. I'm going to add the 10 first. So when you add 10 to 22, you get 32, and then I'm going to divide by that 4, and when I take the 32 and divide by 4, I get an 8, and now I'm going to make my 2 equations, once with 8, once with -8. Notice the x plus 3 stays the same in both equations. When I subtract from 3 in this equation, I get 5, and when I subtract 3 in this equation, I get -11. Now this problem has an alligator, so we will need to see if the alligator's happy. So if you're retaking this, I'm going to change this a little bit on you. You can test in this equation, but you can also test in this simpler equation. So I'm going to write that over here, but not in highlighter. putting that inequality the exact same way it is, and this is just a little bit less to work with. So right now I'm going to be testing. If you look at my answers, negative 11 is on the left side and 5 is on the right. And what number would make this, whoops, I meant to use a highlighter, would make this turn into 0? And that would be negative 3. And negative 3 happens to be right in between those numbers. So if you put a negative 3 into those bars, right? So I'm going to erase the x and put a negative 3 in. When you add that, you get the absolute value of 0. And the absolute value of 0 is 0. And now I want to see, is my alligator happy here? And it's not. It doesn't want to eat 0. It would rather eat 22. So it's not going to be happy in between those two numbers. It's going to be happier on the outside. So here and here. Now, because we have two different areas where it could be happy, we're going to write two interval notations. So for the one on the right with the 5, remember the arrow on the right means infinity. And then for the negative 11, the arrow on the left means negative infinity. Whoops, see infinity. Infinity always gets parentheses. And if you go back to the original problem, this inequality that I'm circling is not underlined, so don't include the 5 in the negative 11, which means you'll put parentheses. And that is showcase number 6 answer key.